So we're looking at the practice final exam. We have this data set spanning years from 2000 to 2017 for Daniel Sedin and Henrik Sedin. All right, so the first 7 questions will refer to the data set, and then after that you'll have some general knowledge questions. All right, so what I did was I typed this information into Desmos, so we're ready to rock and roll here and begin to answer the questions. All right, so number 1, a player entering the NHL has a profile that matched that of Henrik Sedin and plans to model his career path after Henrik's. In 12 out of the 17 years, Henrik earned at least 50 total points. All right. If this new player plays in the NHL for 10 years, what would be his probability of earning at least 50 points in 5 of those years? All right. So the at least part, the 5 out of 10 years, you know, those are terms that kind of make you think along the lines of binomial probability, although the at least part of it is sort of a trick question, or trick to the question. So what we have here is the probability that or that at least 50 points would be 12 out of 17, assuming this trend holds up. All right. So what we want to know is the probability that exactly 5 of 10 years there will be at least 50 points. I cannot write. All right. So if you suspect it's binomial, then what you would do is go down the conditions, or go through the conditions of the binomial distribution, which are a fixed number of trials, fixed probability, independent events, and 2 outcomes. So each of these represents a question. All right. So is there a fixed number of trials? It's 10 years, so it seems like a yes. Fixed probability. Well, we're assuming that the chances of getting at least 50 points is 12 out of 17. So that seems good to go. So we got a check. Independent events. That's a weird one. My 12 looked a little funky here, so I'm going to fix that. Because independent events is telling us that the outcome of an event is not impacted by a previous event occurring. All right, so in this case, we're looking at year to year. So if he earns at least 50 points in one year, does that mean he can no longer earn more than 50 points in another year? I would say I don't know. I'm putting myself in the shoes of a person who has no idea what this NHL thing is all about. I would say I have no idea. But odds are it's going to be a check if all the other 3 conditions are met. All right, so 2 outcomes. Yeah, either you're going to get at least 50 points or you're not. So if we say yes to the first, the second, and the fourth, then it stands to reason that we would say yes to the third as well. All right, even though we don't have any basis to know whether or not that's possible. All right. So that's, again, assuming a person doesn't know anything about the NHL. Right? If a person knows all there is to know about the NHL, then that's a moot point. All right? So we know it's binomial probability, so I would just want to be setting up my notation. You know, in this case, it's multiple choice, but we want to be prepared to have to show a little bit more work. So the probability, again, in at least of getting at least 50 points in the 5 of the 10 years, I would say let X be equal to the number of years you earn at least 50 points. So we would be looking for the probability that X is equal to 5. All right. So whether you do that directly in the calculator or you do it using the formula, that's up to you. If you go in the calculator, it's not bad. It's the binomial theorem or binomial probability, but I'll show you using the rule too. All right, so the rule is NCX P raised to the X Q raised to the N minus X. All right, N is the number of trials. In this case, 10. P is the probability of success. And Q is the probability of failure, which is 1 minus the probability of success. All right, so this would become 10 C5, 12 over 17 to the 5th power, then 5 over 17 to the 10 minus 5 power. All right, so you can crunch that in Desmos if you want. And by the way, again, this 5 over 17, this comes from just doing 1 minus 12 over 17. If you do that in Desmos, it comes up pretty nicely. You're like, oh, that doesn't look nice at all, but then hit the little fraction tool and you see it's pretty nice. All right, so you go into functions. You have all these different possibilities. One, if we're going to do it out using the formula, I would need my NCR analog in Desmos, which is NCR. So I'd select that. I would type in the 10 comma 5. That's 252. You do it on as you go, or you can do it all in one shot. It's really up to you. And there's a shorter way of doing this, but I'll show you this way first. All right. So then I'd multiply this by parentheses 12 over 17. Close it up, square it. Oop, nope. Yeesh. Close it up, square it. Sorry, to the 5th power. Then 5 over 17. Close it up to the 5th power, 10 minus 5. And you get about 0.0972. And then you look at your choices and you see that's one of them. So we're good there. All right, but let me show you the quicker way. All right. So you could go into distribution, select binomial dist. All right. You would have trials and success probability. That's the N and the P. So 10, comma, 12 over 17. Then select cumulative probability. And then just put in whatever, we want it to be X equals 5. So we put in 5 for the low bound and 5 for the high bound. All right, we want it to go from 5 to 5. All right, so that would make it exactly 5, and you get 0.0972. So for number 2, it says, which of the following is the mean for the points total for Daniel Sedin, the population standard deviation for the points total for Henrik Sedin, and the correct statement regarding unusual values for the players. So that would be both of them between 2000 and 2017. All right, so let's focus on the measures of center first. So first thing I would want to do is kind of refresh my memory on which data set is Daniel and which one is Henrik. Daniel is X1, Henrik is X2. Right, so I'm going to make a little note of that. X1, not X2, Y1. Apologies for that. right? So we need the mean for x1. So function stats mean, type in x1. All right, so 61.235. Well, that worked out nicely. All right, but let's just make sure that we're going about this the right way, because, you know, on the test, on the actual exam, it might not be so simple. All right, so the population standard deviation for Henrik. So STDEVP, P for population, Henrik is Y1, 22.467. All right, so good to go there. Then we get into the usual versus unusual. All right, so just a quick refresher. The usual and unusual values are distinguished or delineated or separated or partitioned by this computation, x bar plus or minus 2 times s. Now, this under normal circumstances. Now, this is related to population information. So we would say or mu plus or minus 2 sigma. All right, so we have two individuals here. We have Daniel and we have Henrik. Henrik? No, Henrik. All right, we've already figured out the mean for Daniel, 61.235. We've already figured out the standard deviation for Henrik, 22.467. So let's just go the rest of the way. So standard deviation for Daniel, x1 is what I wanted, 20.871, and let's get the mean for Henrik. And that's y1. So 62.941. All right. So to figure out usual versus unusual, I would compute mu plus or minus 2 sigma for each of these. Okay. So, and we could just do quick number crunching here. For Daniel, it's 61.235 minus 2 times 20.871. I'm just going to duplicate that real quick. Change the minus to a plus. All right, so this is the usual intervals. Usual, you can say usual range if you want. It's going to go from 19.479 to 102.991. So anything outside of these, or the range created by these two bounds, is going to be considered unusual. All right. So that's for Daniel. For Henrik, 62.941 minus 2 times 22.467. Quick duplication. The minus becomes a plus. Usual range. $18.007. $107.875. So now what I would do is go back into my original data set and see if there are any values that are less than 19.479 and more than 102.991 for x1. All right, so anything in x1 less than 19, I'll start with that. 19 and change. I see nothing less than 19 and change in x1. bigger than 102-ish. 102, 103. I got a 104. So my unusuals. I got a 104. And that looks like it. All right. Now for the other guy, Henrik, anything less than 18, or 18 or less. I don't see anything that low. Okay. Now anything bigger than 108-ish. So I got a 112, and that looks like about it. And that's the only thing in the triple digits. All right, so both of them have one unusual value. All right, so that goes hand in hand with what we're saying here. There is at least one unusual value for both sedines. Number 3 is a conditional probability question. It's saying find the probability that the total points is greater than 2010. 2010 is in the number of points that were earned in the year 2010. All right, so I probably could have been a little bit more specific with the framing of that question. All right, given that the individual is Daniel Sedin. All right, so points earned in 2010. All right, so let me rephrase this question based off of the data. It's probability that the total points is greater than whatever the number is for 2010, given that it's Daniel Sedin. So 2010 in the Daniel Sedin column is 104. So I'm looking for the number of values that are greater than 104, but only for Daniel Sedin's information. All right, so focusing only on this first column, that 104 is my cutoff. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 values. All right, so 17 values. And I would want to know how many of them are greater than 104. Well, none of them. So 0 out of 17. So none of these. So for number 4, it says, which of the following is the equation of the line of best fit between total points for Daniel and Henrik Sedin? Based on this answer, what point total would you expect Henrik Sedin to earn in a year that Daniel Sedin earned 90 points? All right, so it's talking about the equation of the line, specifically the line of best fit. All right, so I type the data in. What we're going to do is regress to y1. So I'm going to say y1. I'm going to say tilde a plus b x1. And that gives us a residual, well, we could select residual plot, but that gives us a regression line. Okay, so in Desmos we say y1 tilde a plus b x1, but that translates to y hat is equal to a plus bx. All right, so in this case it would be y hat is equal to the a value 2.606 plus 0.985 x. All right, so I would be looking for the one that's closest to that. It seems to be this one, but there's that second part. It says, based on your answer, what would you expect Henrik to earn in a year that Daniel earned 90 points. So it's saying, what is y hat when x is equal to 90? All right, so what we would just do is type this into Desmos as f of x, write it as a function of x, f of x, 2.606 plus 0.985x, and then just replace the x with a 90. All right, so I'm going to write this as f of x equals, you could use the a's and b's if you want. You could write a plus bx, and it'll use the stored values of a and b. But I'll just write it this way: 2.606 plus 0.985 times x. And you're like, oh, nothing happened. Yeah, but if I turn off my two graphs and turn them on one at a time, they should map to the same location. All right, maybe a little off due to rounding, but it should be in the right smack in the same location. All right, so f of 90 is going to be about, if I'm rounding it, about 91. And there you go. And that's consistent with the choice we selected. All right, so for number 5, there's a couple of ways you could do it. It says box plot is created for the total points of Henrik Sedin, so that's Y1. Make a note of that. Throughout his career, which of the following would be the 5-number summary for this box plot? All right, one way would be to actually use the box plot function. You just type in box plot. You got to type it in correctly, obviously. And then tell Desmos where the data is. Don't select exclude outliers. And then you just have to pinch zoom until the appropriate graph shows up. Now you get the scatter plot there from the raw data. But you could see a little box plot there. Sometimes this method is more trouble than it's worth. If you want to get rid of the scatter plot, you can do that by just tapping on scatter plot. All right. But if you want to make this look a little bit nicer without having to mess around with the domain and the range, what you can do is change the height. Instead of it being 1, make it like 10, and it'll give it more of a presence, I guess. All right. And then you can just kind of eyeball it. I mean, from there, you kind of narrow it down to one of these two possibilities, this one or this one. All right, but it's pretty clearly going to go beyond 100 pretty substantially. So, if you're going to kind of get into the ballpark estimate approach here, you could do it that way, but you could also really kind of zoom in. And if you zoom in far enough, you'll be like, okay, wait a minute. This is 25, that's 30. These are 1-unit tick marks. It's got to be 29. And then the next one, oh, that's a half unit, 41, 2, 3 and a half. Yeah, that looks right. The next one, 55. You have to swipe a little bit to get to 81, but that's correct. And then eventually you get to 112, and you see that it's consistent with that third choice. Now, if you just want Desmos to spit the numbers out at you, then you'd hit Functions, Stats, and select Stats again. All right. So remember, it's Y1 though, because we're talking about Henrik. All right. So just be careful about that. If you select X1, then you're getting Daniel's information, and that might match up with the wrong choice, and you pay a price for that. You see the numbers just appear right here. All right, so you get what you need. So number 6 is a simple random sample of 10 values was taken from the population of yearly points totals of Henrik Sedin, and it's found that the mean and standard deviation were 64.7 and 22.9 respectively. Test the claim at the 5% significance level that the population mean total points earned by Henrik Sedin is more than 62. So in terms of a setup, looks like the benchmark is that mu is going to be either equal to 62 or more than 62. They said alpha is 0.05. The type of distribution, we're looking at a small sample here, so we're talking about a t-test or a t-distribution. You could say either way. All right, now the test statistic. The test statistic is going to be based off the formula T equals x bar minus mu over S over the square root of n. In this case, they tell us that the n is 10. There's 10 values selected at random. The mean is 64.7. And the S is 22.9, 22.9. So you could just pop that information in, along with the assumed value for mu, 64.7 minus 62 over, for equality over, 22.9 over the square root of 10. That's assuming you wanted to do it by hand. All right? It's possible, likely even, that you don't, in which case you go into the calculators that I have for you on Blackboard and select the t-test calculator. All right, it's going to ask you for the significance level, the sample size, which gives you the degrees of freedom, critical values, and all that good stuff. We just need the test statistic, but we do have to put in the sample information. So for this, we just type it in. Oops. Undo. 64.7, 22.9. Parameter, assumed value for mu was 62. Then it'll just tell you what the test statistic is, which is about 0.373. We go 3 significant. And then we just need our p-value. The p-value in the case of this particular test, we're talking about a greater than symbol, so it's going to be a right-tailed situation. So the p-value is going to be about 0.359. So that is a no, because the p-value is not less than the alpha value. So there is insufficient evidence to reject the claim that the population mean total points earned by Henrik Sedin is 62 at the 0.05 significance level. Therefore, the claim that it is more is false. All right, first sentence always addresses the null hypothesis. The second sentence always answers the... All right, so starting with number 8, we're looking at some general knowledge questions. So number 8, if you're presented with a question that requires you to compute the probability of either of two events occurring, so an implied or in there, the correct approach would be to add the two probabilities. If you're presented with a question that requires you to compute the probability of multiple events, kind of get shunted off to the other line there, occurring, the correct approach is to multiply the two probabilities. The evidence, there we go. So, number 9, which of the following is not a condition necessary for a distribution to be considered binomial? So a binomial distribution is fixed number of trials, fixed probability, independent events, and 2 outcomes. All right, so fixed number of trials. Oh, variable number of trials. Well, there you go. That's not fixed. Fixed probability, that's true, you need that. Independent events and 2 outcomes, those are also true, you need those. That's the only one that would not be a condition. So the last question is asking us to make a 5-number selection from the numbers 1 through 6 without replacement. So we can do this a couple of ways. One way would be to just draw out 5 blanks, indicating that we have 5 possible values that can be selected. Right, it's without replacement, so once I use up a value, I can't use it again. So any of the 6 numbers, 1, 2, 3, 4, 5, and 6, could occupy the first position. But then once we make a selection there's only 5 left over for the second position. Once we make a selection there's only 4 left over for the next, 3, and then 2. 6, 5, 4, 3, 2. All right, and so we just do a quick product on a calculator. We can do it right here. And we get, oh, I missed a 4. And you get 720. The other way to do it would be to use a permutation. That would be to say that you have 6 numbers and you can choose arrangements in groups of 5, or select arrangements in groups of 5, so 6p5. This way people tend to understand more, but if you're familiar with the notation, you could say 6p5, which in a calculator would give you 720. All right, you'd have to use a built-in function from Desmos though. Let's see if I can remember where it is, and I don't think I can. Oh yeah, there it is, it's under stats. So stats, NPR, you would type this in as NPR, and then you put in the first number, comma, the second number, so 6, 5. And that would give you the 720.